chapter 4 is about different types of chemical reactions, how to predict products, and how to make sure to come up with the right explanation based on observation that we make in a lab. So I'm starting with this chemical reaction where I am adding a solution which is clear, it doesn't have a color, and it doesn't have any solid in it to another clear solution. And when these two reagents are added together, you see formation of cloudiness, formation of insoluble solids. So this is typical of what we call precipitation reaction. In this case, we are on the left-hand side, I'm using lead nitrate, clear solution inside test tube. Adding to it sodium iodide, clear solution as you see in the droplet. As soon as they are added together, you see formation of this beautiful yellow solid, which is showing that the product is not water soluble. On the right-hand side, again, two solutions, both of them are clear and soluble in water before are added together, you see formation of cloudiness, which are showing that there are insoluble solid forms. So both of these are called precipitation reactions. So how would I define a precipitation reaction? Can I say it's a process in which an insoluble solid, which we call it precipitate, drops out of the solution? So I have the example here that you saw, previous slide, you saw formation of golden insoluble solid of lead iodide. We added lead nitrate and sodium iodide together, and you saw formation of a yellow solid, which is PbI2. You might notice that in showing these reactions, I show the phase of the reactants or product. For example, lead nitrate, which is totally water soluble, it made a clear solution. We call it aqueous, soluble in water. Sodium iodide is soluble in water. It makes a clear solution. We call it aqueous. And we know based on solubility rules, based on table which shows what compounds are water soluble and what are not, we also know, sorry, let me go back. We also know sodium nitrate is water soluble, I write aqueous. And then the solid which was not water soluble, again, based on experimentation, we already know it's PbI2, not NaNO3. So I write S here. So S for solid, aqueous for solutions in water, aqueous and aqueous. So we want to make sure to show the phase of the reactants and product so we can see which one is the precipitate. So if I go to the next slide, another type of chemical reactions that you will see in this course, and it's happening in our body, it's happening in every cell, very important class of chemical reactions, they are called acid-base neutralization. So you have seen this before. If you add an acid, like hydrochloric acid, stomach acid, sodium hydroxide, which is called lye, these two react together, they form salt and water. So acid bases react together to form salt and water. And a third class of chemical reactions are called oxidation reduction reaction. So if you look at these two beakers on the left-hand side, I'm starting by taking a solution of copper sulfate. Copper sulfate breaks down in water. It's converted to copper cation, copper plus 2 ion. So the blue solution is Cu plus 2. And then I placed this gray metal is zinc metal, and these are atoms of zinc. When you place zinc metal inside copper sulfate solution, it means Cu plus 2 is reacting with zinc. Immediately you see this black layer formed on the zinc. Leave it overnight, you see the zinc will dissolve completely. And instead you see these red metals, which are really copper. So the process which is happening here, do you see the blue is gone? It's simply saying that Cu plus 2 is gone, it's reacted. What is it forming? It's making red copper metal. So Cu plus 2 is converted to Cu. And what is zinc doing? How come zinc is dissolving in the solution? If you look at these zinc metals, see what they are doing? They are losing 2 electrons. So zinc with 0 charge, after losing 2 electrons, is going to produce zinc plus 2. And the 2 electrons are going to Cu plus 2 to be converted to Cu. So gradually, as zinc metals are losing electron to copper cation, they are dissolving in water. Why? Because ions are soluble in water. Zinc plus 2 ion is soluble in water. And as Cu plus 2 are gaining electron, they are converted to Cu. And you see the result overnight. All these copper metal are formed because Cu plus 2, which used to be a blue solution, is reacted. The solution is not blue anymore. And Cu plus 2 is becoming all these atoms of Cu. And zinc metal is becoming zinc plus 2, which is dissolved. So you see less zinc metal, maybe a little bit residue here, but most of the zinc metal is dissolved. So this reaction between Cu plus 2 and zinc metal, between Cu plus 2, the blue solution, and zinc metal is called redox reaction, oxidation reduction reaction. What are oxidation reduction reactions? They are electron exchange reaction. Do you see zinc and Cu plus 2 are exchanging their electrons? Another example on the right-hand side, a copper wire, you can see it here because it's covered with silver metal. A copper wire is placed inside silver nitrate. So what is happening? Silver nitrate, which contains silver ion, silver plus 1, is gaining electron. From what? From copper wire. So zinc ion, which is water soluble, by gaining electron, it makes silver metal. Do you see these crystals? A single layer formation of silver crystals, and now overnight they are growing. So what happens to silver ion? It makes silver metal overnight. What happens to copper? Copper wire is losing electron and is becoming Cu plus 2. Remember, the blue color of Cu plus 2 dissolved in water is appearing overnight. So these two reactions are showing redox reactions, electron transfer reaction. These are the reactions which happens in every battery that we are using. They're called electrochemical cell. There is a source of electron giving electron, and there is another reagent which is going to accept electron. So electron transfer happens, electron movement happens, and movement of electrons can produce electrical current. So far we know of 3 types of reaction: precipitation reaction, acid-base reaction, and redox reactions, reduction, oxidation reactions. So this is the reaction we are talking about. Redox reaction is oxidation reduction reaction. Look at this reaction of magnesium metal, S for solid magnesium metal, reacting with iodine gas. Iodine is easily converted, solid iodine is easily converted to gaseous iodine. And at the gas phase, iodine is going to gain electron, magnesium is going to lose electron. So this reaction, Mg has +2 charge, I has -1 charge. While here, I did not have negative charge, it took electron, became negatively charged iodine. Magnesium, which did not have a charge, has lost 2 electrons, is Mg +2 charge here. So this reaction is electron exchange reaction. So if I look at Mg iodide, the charge of magnesium is +2, and the charge of iodine is -1, and you have got 2 iodine, 2 iodide. So the total charge, remember, the total charge of every ionic compound must be 0, because electrons are not created or destroyed in a chemical reaction.